So this first video, I wanted to review what we were working on just before school stopped. So we had been doing mole conversions. So this video should kind of just be a refresher as to what we were doing and remind you how we were doing those calculations. So if you recall, the mole is definitely an important thing to know about in chemistry. It's used all the time. The mole is just an amount, just like 12 is a dozen. 6.022 times 10 to the 23 things is going to be 1 mole of those things. In chemistry, usually we're talking about atoms or molecules, which are very, very tiny. So the mole is a useful unit for us to use to talk about the amount. So if you recall, 1 mole is equal to 6.022 times 10 to the 23 particles. 10 to the 23 atoms or molecules. Replace particles with whatever you're doing in that problem. So we had been using this mole roadmap to practice conversions between moles and mass, moles and volume, moles and particles. In this lesson, I'm going to specifically focus on just the mole to mass conversions. Okay, so the mole to mass conversions will be the ones that we need to use in our stoichiometry calculations. I'm condensing that down into just mass to mass stoichiometry problems. We were going to do all 3 of these, but because we don't have as much time and we missed a couple weeks, we're just going to focus on mass to mole stoichiometry problems, where we're converting from mass of a reactant or a product to the mass of another chemical in that reaction. So if you remember our mole to mass conversions, we needed to do side calculations of molar mass to figure out that conversion. So when we're converting between mass and moles, we're going to need to calculate molar mass. Okay, so the molar mass becomes important. Oh, geez, my writing is not great. So if you recall, the molar mass of like just a pure element, so like let's say we just had all carbon atoms, like diamond or something that was just purely that one type of atom. That becomes a pretty simple, you don't really even have to calculate anything, you just look at the periodic table. So if we look at carbon, let's say we had a pure carbon, so we had a diamond, we had pure carbon. The periodic table says that carbon has a mass of 2.01, it's its atomic mass units. Okay, what that ends up being is equal to the number of grams of carbon you would have in 1 mole of carbon. Okay, and again, this number right here comes from the periodic table. Okay, you just look on, if you look at carbon on the periodic table, you will see 12.01. Usually it's underneath the carbon, but sometimes it would, the C, but sometimes it's on the top too. Depends on the periodic table you're looking at. So for something that's a pure just element, very simple to find the molar mass. When you have a compound, let's say we had H2O. If you have a compound, then you're going to have to do a little bit of a calculation, not too much. But let's say we were trying to find the molar mass of, so let's say we're doing the molar mass of water. Okay, well, water has 2 hydrogen atoms. Okay, so it has 2 hydrogen atoms. Each hydrogen atom, 1.01, depending on how many sig figs, it might not look exactly like that. I'm just going to round all these to 2 significant digits. So 1.01 grams of hydrogen is 1 mole. Okay, but you have 2 hydrogens, so that will come into play in a second. And then we want to find our oxygen. We have 1 oxygen in H2O in water. Oxygen from the periodic table, we know that there's 16.00 grams of oxygen in 1 mole of oxygen. Okay, so to calculate the molar mass down here. So to get the molar mass, we're going to take, so the molar mass of H2O is going to equal, okay, so 2 times 1.01. Oh boy, it's not a good zero. Fix that. 1.01 plus, we just have one oxygen in H2O, so 1 times 16. 0.00. Okay, so from that we find that there is 18.02 grams in 1 mole of water. So if you have 1 mole of water, it's going to have a mass of 18.02 grams. So those are molar mass calculations, and we did quite a bit of that before we stopped going to school. So that is what is needed to convert between mass and moles. Okay, if you're wanting to go from moles to mass, then you're going to multiply by the molar mass. So if you're going this direction here, you're going to mass from moles. Okay, if you're going this way, you will multiply by that molar mass. Okay, and if you're going this way from mass to moles, you want moles on the top, so you got 1 mole divided by the molar mass is going to be your conversion factor there. And we're going to do 2 example problems so that you can understand what that means there. Okay, so moving on, let's do a practice problem because that's really what kind of is the easiest way to figure out what the heck we're doing here. So the first question I have that we're going to practice with is, what is the mass of 8.56 moles of copper sulfate? So a couple key things here. Okay, the mass is what you're trying to find. Okay, mass, oops, I underlined the 8.56, but the mass is what we're trying to find. Okay, and the moles is what we're given. Okay, so if you remember before the break, we actually, we made some cards, some stoichiometry cards, and you may or may not have those. It's not a huge deal if you don't have them, but if you do, it might be a good idea to pause the video and you can go grab them. But you should have a card that says given moles, and we are given moles in this problem right here, 8.56 moles. So we're given moles, and we're trying to get to mass is what we're trying to find. So we're going to need to multiply by the molar mass over 1. Okay, so this will be our setup for the problem. Okay, we're going to take our given moles, multiply by the molar mass. We're dividing by 1, so we're just going to essentially multiply by the molar mass to find out the mass of copper sulfate that we have. In order to do this, though, we need to do a side calculation. Okay, so I'm going to go ahead and we're going to scroll over here, maybe zoom in a little bit, and let's do a side calculation of calculating the molar mass. So here we have copper sulfate is what we're looking for. So just going to let me choose. There you go. So copper sulfate, let's do a side calculation here for the molar mass of copper sulfate. Okay, so we have Cu. Let me grab my notes here. I've actually already looked these all up, so I don't have to do it as we're doing this. So Cu, if you find a copper on the periodic table, the atomic mass of copper, 63.55. Okay, sulfur is 32.06. Okay, and then oxygen we actually already knew from the other practice we were doing, but oxygen is 16.00, but we have 4 oxygens, so we're going to actually end up multiplying that by 4. Okay, so scroll down a little bit here. So to calculate molar mass copper sulfate, we take 1 times 63.55 plus, oh, that's a 0.55, plus 32.06, and there's just one of them, so just 32.06 plus 4 times 16 equals, and what we get when we do that on the calculator is 159.61 grams per mole. What that grams per mole means is that, oops, I knew I was going to do that, in that 1 mole of copper sulfate will be 159.61 grams. Okay, so in this problem, though, if we go way back to the problem that we were given, we have not 1 mole, we have 8.56 moles of copper sulfate. Okay, so going back here, so we're going to use this as our template right here. Okay, and I'm going to set up this same deal, but I'm going to plug in the numbers. Okay, so the given moles I find from the problem up here. Okay, 8.56 moles. Okay, times, I know I'm going to have 1 mole in the denominator, and in the numerator, the molar mass that I just calculated over here was 159.61. There's that much copper sulfate in 1 mole. Okay, so when we end up doing the math, we end up getting 1366 point, and it goes on, 26, goes on, but because of significant digits, our 8.56 only has 3 significant digits. So the answer that we're going to report is 1370 grams of copper sulfate. Okay, so we have gone from knowing that there was 8.56 moles, and now we know, okay, well, if we're trying to measure out 8.56 moles, that would be 1,370 grams of copper sulfate. Okay, the last practice problem I have for you here, and I'm going to have to give myself a little bit more space. Delete that. Okay, diamond is a solid form of pure carbon. The question is how many moles of carbon atoms are in 0.75 in a 0.75 gram diamond. So I've already have the flashcards, how you could have them set up if you are using the flashcards. Okay, so we're going to take the given mass, which we have right here. This is our given, and it's in grams, so we know it's mass. Okay, but we're going to need to divide by the molar mass. Okay, so we need to do a side calculation again. However, this time it's just carbon. And carbon, we know from the periodic table that the molar mass of carbon, oops, yeah, whenever I touch the screen. So the molar mass of carbon, straight off the periodic table, 12.01 grams per mole. Okay, so if we're going to set up our problem, again, using this as a template, okay, our given mass is 0.75 grams. Okay, write it down and underline it. Okay, and then we're going to do a multiplication sign, and we have the molar mass is going to go in the denominator, and the molar mass always has units of grams by the number, and then 1 is in front of the mole. So we got molar 12.01 grams, 1 mole of carbon. And again, we can do this because this says diamond is a solid form of pure carbon. So we're assuming that all of the atoms in there, all the mass comes from carbon atoms. Okay, so on the calculator, let me draw a line here so we don't confuse over here with what we're doing. So we multiply across the top, we get 0.75 points. That's a big point, but and then we're going to divide by 12.01. Do the math on your calculator and round to 2 sig figs because the 0.75 has 2 significant digits, and we get that that is 0.062 moles of carbon, which is, remember, 1 mole is 6.022 times 10 to the 23 atoms, so it's a lot of atoms, even though this number of moles is relatively small. And that makes sense because if we had 1 mole, the mass would be about 12 grams. So we only have 0.75 grams, so our number makes sense. It makes sense that we have a fraction of a mole and a pretty small fraction of a mole for our answer. Okay, so those are the 2 practice problems I have for you. We also had the chalk lab, and we had some practice problems we did as homework and in class. So those would be good things to review on Google Classroom to if you're still wanting more practice for this. But make sure you understand how to do these calculations, because when we move into stoichiometry, which is the actual lesson for this week, we use these calculations from mass to moles and moles to mass quite a bit. Okay, thanks for watching. I hope you learned something.